Okay, continuing on. This is where we get to our sum and difference identities that we want to use for this. So for tangent, looking like a good sum here. What two angles added together equal 165, and at the same time our angles on our unit circle kind of idea. The first one that comes to mind is 120, which is a 60 in quadrant 2 plus 45. So that's the objective on these kind of questions. Find the two angles that add or subtract to equal that, and then use the classic sum identity in this case for tangent, which is tan plus tan divided by 1 minus tan tan. So if you were going to have to memorize those, you don't. Just talking through how I have them memorized. Put those little degree marks on there. And then if it needs to be that you go in a coordinate plane and draw that 60, side opposite to 60 is root 3. This is why I like this chapter because it reminds you of those things. Side opposite 30 is 1, hypotenuse is 2, or divide it all by 2, and that's where you get the root 3 over 2, 1/2, and 1 for the unit circle, whatever. Tangent of 60, or that 60 in quadrant 2 is y over x, so it's negative root 3. That's what you're going to find replaced in this position. The tan of an angle equals a ratio of sides, in this case root 3 over 1. Then 45 is in quadrant 1, and that's 1, 1, root 2, or divide everything by root 2, and you get root 2 over 2, root 2 over 2, and 1. Whatever you do, the tangent of 45 is y over x, which is 1. And then that's what ends up happening down here, 1 minus these two multiplied together again. All right, then the problem is in this one, minus a negative. This ends up being 1 plus root 3, and now it's a math 2 question, or whatever you did, radicals, simplifying, or in this case, rationalizing. And I'm just going to change colors to get you to understand that this is out of my brain, that I multiply the top and bottom by the conjugate of the bottom. The point of that is 1 times 1 is 1 on the bottom. These cancel, negative root 3 and positive root 3. And then negative root 3 times positive root 3 is negative 3. All right, and then you don't have a radical in the denominator anymore. That's the whole point of rationalizing a denominator. In the numerator, not quite the same thing, so be careful, tread lightly. This is negative root 3. Hard to write on this. And then negative root 3 times negative root 3 is a free positive 3. Negative times a negative. And then 1 times 1 is 1. And then 1 times negative root 3 is another negative root 3. So those don't cancel. What you end up with is 4 minus 2 of these root 3's over a negative 2. 1 minus negative 3. And then when you divide these, no, don't do a 6 over 5 equals 2 error. Just cancel those edges there. No, you have to basically divide both of these by 2. Trying to get that out of there. So 4 divided by negative 2 is negative 2, and then negative 2 root 3 divided by negative 2 is positive root 3. And then that's how you end up getting the exact answer for an angle measure we were not able to get an exact answer for before. Okay, so just keep in mind what we're trying to do there for sum or differences. I am not changing that to degrees. I refuse. Because I know 5 pi is 3 pi plus 2 pi, and 3 pi over 12 plus 2 pi over 12 equals 5 pi over 12. And 3 pi over 12, I'm just going to write this above there, is pi over 4, which is the classic 45. 2 pi over 12 is pi over 6. So I'm getting kind of messy on my work. Let's not do that. Cosine of pi over 4 plus pi over 6 then, in making that decision. And in doing that, Now I can use the sum rule for cosine, which is cosine minus. That's just the rule that you don't have to have memorized, but it would be on a formula sheet, so on and so on and so forth. By the way, as I'm writing this down and you have your tests coming up, obviously we're not going to see you, so you're going to have your own formula sheets out in front of you. So make sure you're aware of that. And then the cosine of a 45. Again, that's why I love this chapter. You got to know this stuff. You got to know it quick. 45 is 1 root 2 in my class. Cosine is x over r, root 2 over 2 from doing chapter 2 and chapter 3 for so long. And then pi over 6 is a 30 in quadrant 1. I just snapped these real quick. 30. Side opposite 30 is 1. Side opposite the 60 is root 3. So cosine of pi over 6 is root 3 over 2. Minus sine of pi over 4, same thing. 1 over root 2 or root 2 over 2. Should recognize those from doing those forever. Then sine of pi over 6, sine of a 60 is 1/2. 30, I meant 30. Slipped out my mouth there, the wrong answer. All right, and then this is root 6 minus root 2. From doing your homework last week, we saw this answer quite a bit. So hopefully you're just getting used to how the formulaic, idea of these identities are and how they get inserted in their parts and how we end up with those answers at the end. And these are my favorite. They're the reverse identity ones that I did do in the notes before. This is the classic sum rule for sine. If you look at the formula and how it's lined up, it's an identity, but I like calling it a formula. This is the sine of A plus B situation. So this is the sine of 25 plus 35. I think we had this in our notes last week that you watched. You better have, or else you're going to be severely behind. And then sine of a 60. Well, sine of a 60 is root 3 over 2 from chapter 2 and 3. So real quick, again, I don't know what you do in your class. If you're looking at that unit circle, doing your fingers thing, whatever. At this point, I got to memorize, but I always can fall back to that 30, 60, 90 right triangle. Sine is y over r. We should at least know that. And then this is our classic tan of a plus b, if you look at your identities there. So this is tan of 10 plus 20. Well, that's tan of 30, and tan of a 30-degree angle can be evaluated. So if it was like tan of 40, then you'd be done. But 30 is one of our classic angle measures. 40 is not. So that may be confusing. Like some of your homework assignments might have just let you have tan of 40. But if we can evaluate tan of 30 and get an exact value, then we go ahead and do it. Side opposite 30 is 1. Tan is y over r. 1 over root 3 or root 3 over 3. Or however way you do it, your fast way. Okay? All right, so just so you know that. All right, and then the point of these questions, do I have another one that leaks over here? I'm going to finish the video with this and then end the last video with the verifying identities. Okay, so this one is the cofunction idea. Because 59 degrees and 31 degrees are complements. In my class, I tried to give a mnemonic device. Complement relationships are the cofunction identities. So sine of an angle equals, well, sine was related to cosine, and it was cosine 90 minus whatever the sine of that angle measures. So this should say cosine of 31, but what's this 1 over? Well, what's cosine equal to? 1 over what? And the answer is secant. So they did a double identity on you there. The cofunction complement idea, and then cosine of 31 is 1 over secant, blah, 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 blah. All right, and then the same thing with this. This was already tested of you. You already had this on a test before our quarantine. How could secant equal cosecant? The only way they could equal, one way that I showed was this. The only way that could be equal is if these two angles are That's a theta. I'm going to clean that up. These two angles are complementary. So I told my class, if you recognize that, then this is what is true. And that's the direct way of solving for this. So again, secant equals cosecant of the complement. So these two add up to 90 degrees. And that's the easiest and most direct way to do this question. Well, I'll be darned. That worked out so nicely. So theta equals 10. Okay, you finish that off. Okay, all right. So that's good for that section, and then we'll get the last section in the last video.